My name is Sue Gross, and I'm from the Minnesota Bureau of Criminal Apprehension, and I'm going to be the moderator for this next session, which is entitled New Developments in Manufacturing Materials. And this morning's session is going to describe some of the changes in the past 10 years with manufacturing. Our first speaker is Kenneth Perry. Ken has been with the BASF Coatings since 1980. He received his MS in chemistry from the University of Detroit and an MBA from the University of Detroit. In addition, he earned his master's in education from the University of Phoenix. Ken has served in many positions and functions while at BASF, including color development, product development, polymer development, quality systems, product stewardship, technical service, and as a site manager. Ken will be talking to us today on the advances in automotive coatings technology.
Thank you. Good morning. When they told me to talk about paint, I'm always a little concerned about if you know much about paint and how much detail I can get into. But Chris mentioned two words this morning that I'm going to try to convey or follow through on, I guess. And the one is cool, because I think paint is really cool, and passion, a lot of passion around the work. And then I was going to save it to the end maybe, but I'd like to extend an invitation already to compare best practices in analytics, because we do a lot of analysis in paint, and I think we really don't share those things up front. So through the rest of the day and tomorrow I'll be around, and anybody who'd like to talk about some potential collaboration, I'd like to offer that up. So, little things in order here. Got a couple a little out of order here, and I didn't get a chance to change them, so bear with me. I want to talk today about trends and drivers in the market, so the idea about what's coming, what's changing, and how that's happening. When everyone talks about paint or analysis, it's usually what color is it? Make, model, year, and color. And when most people go to buy a car, they talk about color. So I'll get into a lot of ideas on what's happening in color and show you some neat pictures, hopefully. We talk about integrated processes because most of the work of the last several years has not been on materials, it's been on process. And that really doesn't change the analysis, I guess, but it indicates where things might have been made. If you're in the industry, especially automotive industry, and you drive down the street, you can say, you know, that was made in Georgetown, that one was imported, that one's made by our competition. You can pick out your colors and you can pick out the years and the technology driving by, because all the processes are somewhat unique. And then talk about laminates, if you will. A lot of people, most people that paint, their project is some way trying to not paint. I think even at home, people just don't like to paint. You know, but the reality is everything is coated. So when we talk about paint, we talk about coatings. Textiles are coated, you know, buildings are coated, roads are coated, everything is coated. So in some way, shape, or form, you have a film on your materials. So when we look at trends, there's lots of things here. Typically, of course, the legislation and the environment move the technologies. Around this wheel here, you'll see we talk about VOCs, volatile organic contaminants, which is a main component of most paints. They always want these to be lower, lower, lower. I'll talk a little bit about that. The other main thing is always heavy metals. Anything that's heavy metal is supposed to go away. My favorite music is heavy metal, so I always have a problem with people kind of bad-mouthing it, but things like lead and chrome and things need to go away. And these have always been key points in paint. And then there's other things just like general environment, just moving upstream in the life cycle and eliminating things from use, if you will. So a lot of materials are just, you know, being removed from use. And again, since coatings go on everything, like food containers and toys, you can imagine, you know, like trying to get rid of phthalates because kids eat them, and school bus yellow because kids seem to eat school bus paint. You know, you have to get things away from kids normally. So again, you have to be very careful on what you put in your paint. So when we look at say over time, just to bring us up to the present, we started painting cars here back in the the early 1900s here. And everyone talks a story about Henry Ford and all you could get was black. And so our story, part of that is the reason for black was, one, it was inexpensive. It was easy, if you will. It hides things. But the main thing was it dried faster than anything else. So the story behind it is it dried faster than anything else. And when Henry Ford looked at what he wanted to do, he put the cheapest paint on that dried the fastest. We're still trying to do that all the time. The cheapest paint that dries the fastest is still what we're working on. But people won't go with black only. It would sure help us a lot. As we move through time and look at the VOCs, we start in this 7 pounds per gallon area. So 7 pounds of solvent in a gallon. A gallon, if you will, of water weighs about 8 pounds. So at 7 pounds, you were mostly solvent, right? There was hardly any paint in there. And now systems are down in the 2 to 3 range. And this seems to be generally the limit of what you can do unless you use only water. And environmentally, a lot of people would say, let's just use water. But actually, in the life cycle, water is harder to clean and harder to dry. So in the end, solvents really end up being the best ecological choice. So we're really at that limit there where we don't see much more movement, driving that part of it. So the heavy metals and the other chemistries are there, but not really the VOCs. Along with whenever there's a change for ecological reasons, we try to impart and improve, let's say, the paint system. So we work on weathering, if you will. Currently, an automotive car is expected the paint to last about 10 years. The average time a person keeps a car is about 6 years. So really, it's supposed to make it to the next guy, right? That's the idea. Always you want it to be high glossy and non-yellowing and not crack. Lately, the big things driving the consumer end of the market is scratch and dirt. You want it to not get dirty, and if it does get dirty, you want it to clean easy. Those two things actually contradict each other somewhat. And then scratch and mar. You don't want it to go through a car wash and have scratches and etches and things like that. So as we go through, again, the technology is lowering and lowering the ecological footprint, but also the performance is supposed to improve. So I guess, does everyone think their car paint lasts long enough these days? I mean, does anyone really complain? Because from my side, I never hear anyone complain about their car paint. Everything else goes wrong first. I mean, the transmission, they guarantee for 100,000 miles, and the paint was only for 10 years. So, again, I'll talk about a little bit this later, but what you start to see now is that working on the process. So you don't want to bake paint if you can get away with it. You'd like it to cure it, in the air, if you will, relatively quickly. So things like ultraviolet curing, electron curing, those things. The way you spray paint, you're using electrostatic spray equipment to put it on efficiently. And then we're moving towards upstream, the raw materials being made, by biomass materials. So making paint from soybeans, making paint from corn, those kind of things. And even in the manufacturing side, using natural catalysis or enzymes instead of cooking or heating things up. So a lot of work around the process side of things. So, cool cars are timeless, right? And I mean, again, you say color and technique, and there's a lot involved in the trends of colors and how do people select colors and things like that. We actually participate, and BSF's in a lot of other markets, but we have design centers and stylists, and they go to fashion shows. So here they are in the paint department working for me in chemistry, and I have to have someone go to Paris, and they hate that, right? But we really, because the colors we're working on right now are for 5 years from now or more, or at least further out. So it takes us 3 years to get a color approved. It takes us about 3 years to pick one. So they really do go to the textile industries and the art shows and things like that. And so just an idea here, for example, there's a lot of this futuristic metal look. Some people like it. It looks more space age, if you will. Other people think it looks too mechanical, and they would like things softer. But you're always choosing, what kind of paint you'd want. And the little caption there, of course, we've been painting for a long time. When you look at colors then and trends, covering, I guess, a long period of time here, when I look at this chart, it tells me things don't change. Other people say, well, greens are up, or it's a busy year for blue or something. But what you always see is white is still the #1 color. And that's pretty boring. But, and there's a lot of things in white, but white's the #1 color. Gray here is really, not gray per se, is silver or light metallic. And black is always there. So you take those 3 colors, all you have to supply is 3 colors and you have 50% of the market. But all the other colors are down in this other stuff. So we have always some reds and blues. And greens did kind of come and go here. We think they're coming back. But again, we match this and try to offer something in every category. So if we talk about the process, and I talk about integrative processes, what does this mean? They're trying to eliminate some of the coating, or some of the baking, or some of the process. So that lowers their energy, which of course is CO2 emissions and other things. But along with that, it's a smaller plant, so there's less construction, there's less heating and cooling, there's less floor space, there's a lot of benefits to the process side, and of course there's a lot less waste. So again, as I mentioned earlier, what they really are trying to do is eliminate as much of the paint as they can. So for us, we want to still get the performance that they want and the color and the gloss they want while eliminating steps. It's a little busy here maybe, but just to give you an idea of how a car plant operates, there's an electrocoat deposition place, so every car is dipped completely in a bath of coatings, and it comes out of there and it's cured. So this process takes around 2 hours, and it's heated to 350 degrees Fahrenheit for an hour. Then you put a primer on it, which helps give you some smoothness and some protection and covers up some areas. And the base coat is where we put our color in, and then a clear coat. So most cars right now have these 4 steps. And the color is in the middle here, and the clear coat gives you your performance. What they want to do with most of this, if you can imagine, they want to do it what they call wet on wet on wet. So right now, we do the E-coat and we bake it, we do the primer and we bake it, we do the base coat and clear coat and bake it. They would like this to be wet on wet on wet and bake it. Now, every layer loses some identity when you don't bake it. So they mix together, and from an identification point of view, they're blended together more. There's not distinct layers. It makes it a little more difficult. It also is a lot more difficult to have multiple vendors, because if I'm using the other guy's primer and anything goes wrong, I'm sure that it's his fault, right? And so that always comes up. So this also drives you towards more a full assembly plant supply. So color and appearance, again, are more difficult. As these layers are less and less distinct, the things you could impart to them, especially color, is more difficult. If the color bleeds into the primer or bleeds into the clear coat, the crispness of it and the clarity of it is lost. You can imagine, like when you're painting your house, if you try to do that second coat before it's dry, right? All kinds of bad things happen. So it's becoming more and more difficult, and at the same time, the colors themselves are becoming more complicated, if you will. So let's talk about color. A little bit about the market here. As I mentioned, mostly it's black and white and gray, shades of gray we call it. Everything's just shades of gray. But if you look at the actual numbers of what we purchase, so titanium dioxide, which is the white, is a major portion of the materials. Iron oxides, which is in most reds, is a next major player, and carbon black. Okay, sorry for that. I didn't know it was going to do this to me. So if we look at pigments, there's a variety of types of pigments. Pigments is a very large category. But we have things like aluminums, micas, glass flakes, and really, apart from the organic pigments, most of the pigments here are going towards this kind of a synthetic approach to some degree. So you have some substrate, which could be a variety of materials. And then around that material, to stabilize it and to make it easy to ship and to make it store, they put a layer over it. And the thickness of this layer and the refractive index impart some of your color. And then also you want to make sure that this pigment is durable, because the thing that fails in paint is the pigment. The resin is there to protect the pigment, so in some way you coat all your pigments. And again, depending on how you manage these things and choose the ratios of them, you change your chroma, your opacity, your appearance, and your durability. So you're taking what used to be just organic things out of the ground, that you just threw in paint, which was very hard to control and very hard to standardize, and now they're basically creating materials from scratch. You see some of this effect, and we talk about mimicking nature. So from an analytical point of view, what makes that beetle look like that? What's in that shell or whatever, and can you go in there and determine what's in there and make it? So then we like to show the beetle too, but by the way, all of the beetles are produced in Puebla, Mexico by BASF, so that's an interesting thing too. But in very many cases, you'll see, like if you look at whatever you want to, people talked about feathers, but birds and insects and butterflies and the whole range of things on color, most of these things are available to analyze and determine how we make them. So again, how do you get color, or how does this make a difference? Well, the angle of the light and the type of light that shines on something, and then how it's refracted, at what angle it's refracted. So one of the things that's happening is it's very sophisticated. People are trying to, with spectrophotometry, match colors, and electronically, if you will, produce colors. But the range of the eye is across all degrees, right? So any instrument right now, the best instruments have 5 or 7 angles. But now they're coming out with better computers of having spectrophotometers that will do full 360-degree angle color determination. The problem for us, you can imagine, is someone wants you to match at 360 degrees. Because these colors, since they have this thing, and as you move a color, it changes color, right? So we call it flop or index. But the idea of that flop is when a car goes by, it looks like it has more angles and more design to it than it does, because the angle changes and the color changes. So when you try to make a car aerodynamic, you get rid of all the angles, and then you try to impart angles with paint. Well, if you're trying to match at every angle, it's really difficult to convince somebody that every angle is the same for every color. And as you start to talk about analysis or looking at this, so if we look at the various substrates, you'll start to see the, if you will, morphology of some of these things and the complications on which ones you use and who uses what. Very thin plates, very crystalline structures, if you will. And we look at some specific examples. For example, take TiO2, so just white, that's normally white, put it over a mica, and you'll have a silver effect. You increase the thickness, if you will, and you get a change in color. Now, these aren't all specific, but you move the color by changing the thickness of the layer on the substrate. If you use iron oxide in similar things, you get different colors again at different at film build. So when they're manufacturing these, their ability to control that thickness is key. And again, if you're going to then analyze these, you can tell exactly where something came from, because this is a very rigorous kind of manufacturing system. And of course, then you can start combining things for other effects. So there's really almost no limit to how many different things we can do here to create, if you will, artificial colors, but very specific colors. Again, when you start to look at these analysis, you want to look at how well is it laid down, how uniform is it laid down, are there any voids in the system or whatever. So we go through here, and as we create colors, we go through and if you will, map out and identify them. And you get some of this kind of, again, look, maybe you can't see it. These are the very colors that look very metallic, but very soft, and yet have a lot of undertones in them. So it's all of these are made with completely synthetic materials. Now I want to talk a little bit about cool pigments again. So it's specifically called cool pigments. I think everyone knows that like a black car gets hotter than a white car. So again, if we switch from Henry Ford, we'd want to have only white cars because they're in that sense much cooler. But what you really find is that every pigment has a certain amount of reflectance and absorption. And it's not straightforward between black and white, which colors are the coolest, if you will. And there's a lot of work going on here. Currently, we supply coatings for roofs. And if you put cool roofs on, you may have even seen some of this in the advertising, it makes a significant difference in your energy savings for the homes, especially for buildings. If you do a whole building in cool pigment, it has a tremendous effect on the ability to heat and cool the place. So people are putting it in textiles also, you know, and things like that, so that your outdoor, like exercise equipment can keep you cooler. In cars, it's not as straightforward because of the windows. Most of the heat that's generated is trapped inside, but the windows have more effect than the paint. But if you do all the cars in a community, the heat effect in the community is reduced. So there's a lot of studies going on how do you value that effect and how many colors would you supply. So for our styling show this year, we showed only cool colors. You know, that was our plan. BSF has only cool paint. And it's actually a tremendous market-like acceptance for this. As I mentioned, it's not clear on which pigments and how they would respond. So we go through and we're taking all the current pigments and analyzing them, how they respond. And then we're also looking at the synthetic pigments I told you about to say, how can we create cooler pigments? Just so you know, I mean, again, what happens here is the color you see is in the visible range, of course, but in the infrared range, there's a lot of effects here that you won't see the changes we make if we do it right. We can make them cooler, but it'll be by using things that don't reflect in the visible range, because people still want the cars to look good. This is a demonstration to show, you might not be able to see all the subtleties, but in the visible light, you have this color look. And you'd say, well, dark is hot and light is cool, if you will. But when you look under the infrared light, you'll see it's not always true. You know, that not everything dark is light, if you will. And specifically on the street sign, and the red shows up as being a much different than visually you can detect. So again, it's not intuitive how you do this. So what happens here, again, the light and energy can either go through the paint or it can be reflected out. So typically it goes through the clear to the base coat where your color is, but you can construct the base coat such that it goes through to the primer also. So it's a question of which layer do you want to do this in and which pigments are available for you to work on. So we're trying to get away from this only black or white and keeping the substrate, the car, the home, and then the textiles at a cooler temperature. So again, we're looking at trying to incorporate this into all of our coatings businesses. So looking at the limitations of the colors, the heat island effect in communities, how much that affects air conditioning and energy and customer comfort. But I think you'll see across the industry and all of coatings, you'll see a real shift towards these type of pigments in the future. But it can get complicated. So I show you that the legislation keeps changing, the process keeps changing, the pigments keep changing, but people want cool cars. There's not much you can do about it. And so it's really fun, I guess. Again, they say that you know, this particular car, that's hand painted by some guy. You know, and maybe you've seen some of these like large recreational vehicles that are airbrushed and things. You know, it's pretty amazing to take an artist and have him, you know, airbrush a wolf on a bus in a couple of days, but and still do all the other things he's supposed to do. So it is pretty cool. I want to talk about a little bit about functional pigments, and what I mean by that is that they're not just for color. Pigments, you know, impart mechanical properties and other things to your paint, and an effect here we call it a magnetic imager effect. And again, it's a little hard to see without the actual panel here. But what we're able to do is we take a magnet and we design the magnet in a certain shape, and we put this magnet to the metal, and then we paint it. And the paint will align with the magnet. Again, really sophisticated, but you know, It makes things very aerodynamic and, you know, very sleek looking, very futuristic looking. Okay? So I got a lot, I'm throwing a lot out here, a lot of different topics, but I'm trying to cover all of paint. So I want to talk a little bit about UV coatings, if you will, but really more or less films. For UV film, the idea here is the person normally painting the car doesn't want to paint, I told you. So he buys pre-painted parts, if you want to say that. So instead of painting the door and hood, he's going to get a skin or a film and kind of shrink wrap it on the car, okay? So someone else is going to do it. The thing about this is it gives you a much better appearance, what we call a Class A finish on plastic and parts that you can't get right now. It gives you improved scratch and mar, which a lot of people are asking for. And of course, for the automotive person, there's no spray equipment or anything to do. This is all done kind of in a dipping process. So the VOCs are less, the energy is less. So this gives us all of the things I was kind of trying to show you to some degree. It starts to make everything easier again instead of more difficult. So as I said, we take the part, we create this sheet of plastic or adhesive, if you will. We send it through a roller to form to the part, and we put our coating on there, and then that part is sent to the manufacturer. So the other thing this does is it also standardizes it now, because if everyone's using these parts from this guy as opposed to all doing their own, there'll much be more consistency in the process and throughout the supply chain, if you will. This is what it looks like. So, you know, this is a Ford, if you will, Ford red, and it's coming through on sheets that looks, you know, very much just like a laminate or a textile. And this would be sent to the car, and they'd shrink wrap it on your car instead of painting it. So we're, you know, I'm kind of wrapping up here, but I don't know how many are familiar with the E7. I'll show you a picture in a second, but we were approached by Carbon Motors to say, let's talk about painting a car in the future. What would it look like? And specifically, a police enforcement vehicle. If we, instead of using a Crown Vic or a Mustang, which you normally see, they want to say, what would we create if we created it, you know, separately on our own? And what would we do about painting? Well, they don't want to paint, so they're going to use film only. And they don't want to necessarily use labels, so we're going to embed logos into it. They don't want to put decals on it, so we're going to have fluorescent paint to show off the 911 and the local areas. So trying to incorporate all of our tricks of paint, if you will, into this vehicle. It's all plastic. It's got Kevlar in it to be bulletproof. It's like I said, you got print-on-demand graphics. The dashboard is all without labels and everything, if you will. And the website will be here. You can see this if you haven't, but this is the Interceptor. It's been traveling around the country. They just decided a couple weeks ago they're going to make it in Indiana. We were hoping they'd make it in Detroit. It's been in our lab for a while. It's gotten a lot of attention. But for us, this is pretty exciting because this, as I mentioned, all of our tricks are in here, if you will. You know, it's cool. It's got film. It's got embedded color. It's all on plastic. And I guess the reason for this thing, I say this is where paint's going. And these guys are going to be first. They're back ordered 10,000 units, and they don't start production for 2 years. So the automotive market will recover, I guess. I think we're coming back slowly but surely. But still, cool cars are timeless. This is a 1957 Gullwing. They only made 100 of them. We've got, I think, the last remaining one in the lobby, and it's really interesting to. It's still the same paint we're using today mostly. So I'd like to thank you guys for having me. Specifically Lee, thanks a lot. I had a great time already. Thanks for last night. Oh, I meant dinner. Dinner. Oh, sorry, Lee. And especially everyone at BSF for putting up with me for all this time. So I think I have time for questions. Any questions? Thank
1
you. Nothing?
Any questions out there?
Paint, BASF, last night.
I have one. What is the status of powder coatings?
Yeah, powder. I didn't talk much about powder. When we were driving VOCs down, everyone said, well, why don't you get rid of all the water and all the solvent and have a dry coating that you put on electrostatically. And it's very low cost and very efficient. The thing is, with ovens and temperature driving things, it's the most expensive paint to cure. It only cures at high temperatures. You have to melt it, if you will. So the performance is good and the cost is good, but it doesn't have Class A surfaces appearance-wise, and it's very expensive to process. So really you're seeing it go away other than places that already exist and do small parts. So it's mostly fading out, let's say.
Any other questions for Ken? Okay.
Okay, thank you.